All right. Yeah. Thank you. Yeah, I just want to say I love libp2p, but like when we try to upgrade between versions, it's a nightmare. But yeah, apart from that, yeah, it's really great. So sucking up check, desync check, and there's a sandwich for sucking up again. All right, clicker maybe. And it's a laser. Oh, nice. Cool. All right. That's not me. That's not me as well. What? Is it the other way? Oh, all right. Cool. Anyway, so I'm Paweł. I'm from Chronicle, and we run oracles. First of all, I'd like to know, do you guys know what oracles are in blockchains? Ooh, that's nice. All right, so this is me. I'm an engineer at Chronicle and also a co-founder of It Warsaw Hackathon. But oracles. So blockchains are blind. They do not see anything beyond themselves. That's why we need oracles. So systems that make external data available to the blockchains during transaction execution. Everything beyond that is not really an oracle from my perspective, because when you have data, your protocol is on one chain and then the data is somewhere else, then if that data availability layer, as some people call it, is gone, then you're basically screwed. And if the data is on the same chain, it's available every time you need to do a transaction. And like if the chain would be broken, then we would have a bigger problem than oracles. So to me, the best oracles are actually on the same chain as the protocol that they are getting data to. So basically securing. And there is no DeFi without oracles, because we want pricing data, we want some other information that we use for something, and then DeFi actually needs that very much, and not everything is available on chain. So yeah, that's the deal. How oracles work? They work very simply. Like the idea is simple. They collect data, they sign the data, and then they store it on chain. As you can see, like I stole the logo from DEF CON, but yeah. Then to make it more efficient and more secure, we need more validators that collect data. They sign the data and they store it on chain. But that was fun and fine when gas was cheap. Right now, when Ether is, of course, mooning, and we love that, but when gas is not cheap, and sometimes it actually even was about 200 gwei, then a transaction becomes very expensive. And if we had, because the previous version and initially oracles stored, like every validator stored data on chain separately, then that was super expensive. And we are using 13 out of 25 quorum, so to be secure and sure that everything's correct. And that would be like 13 EC recovers, that would be too much. We, of course, upgraded a few times, and right now what we have a distributed network of validators. They use libp2p to send data to relays, and those relays store the data. But we've got 13 signatures collected from validators, but only one transaction. This is really cool, and it's still an aggregation of 13 signatures that needed to be verified previously, because we since upgraded to signature aggregation with Schnorr. But because we are at a libp2p day, we won't be talking about this encryptions and stuff. I would like to just show you how we are using libp2p for our network. So, as I said, we've got a mesh network of nodes, which is obvious that like that's how peer-to-peer works, at least in our case. And we are using a bunch of modules from the P2P stack. We're using most of the transport happens on TCP. We use circuit relay and autonat to get the messages out if it's not possible to do directly. Then we of course use distributed hash tables in peer routing, and all of the messages get we create a gossip sub network to communicate all of the messages. The messages are simple prices. Yeah.
What implementation do you use?
The Go. Yeah, I was getting to that because I put a gopher here. Anyway, yeah, we are using Go implementation, and we have been using libp2p for about 5 years now. So yeah, we started I think the biggest signal for using libp2p was when Ethereum announced they're gonna be using libp2p for the Ethereum 2, you know what I mean, like the next version. So yeah, we are using that. We are using the Ethereum key type. We didn't want to use separate keys for signing things for Ethereum contracts and for the transport layer. So we are using ECDSA. And yeah, we've got our own implementation. That's why we just added our own key type here. But I think in the some of the latest versions, there's already an Ethereum compatible key in libp2p. But never mind that. This is how we got the signatures, and all of the messages get signed by Ethereum key, so we can easily verify that in the mesh network that we create, the only participants that are able to create messages, to publish them, are the ones that are authorized. It's called lifted on our contracts in the MakerDAO ecosystem, because we actually evolved and spun out of MakerDAO. So we've been doing Oracle since 2017. So I think we know what we're doing. Yeah, so we verified that the only ones able to publish in the libp2p network are the ones lifted on the contracts, and we just verify if it's the same address that we have in our permission list. Then another module that we extensively use in libp2p, from libp2p in our code, is peer scoring. Because we have specific rules on who can publish and when they can publish. We have a limit on how many messages they can send. We've got a limit of what messages they can send, and if they start sending bad messages or start misbehaving, we just give them a bad scoring, and after a while they'll be kicked out from the network. Yeah, all of that is fun, but for anyone trying to use libp2p, I've got an important note. When you want to use gossip sub, so you want to send out messages to the network, you need to subscribe to channels. Yeah, like that's one of the funny mistakes that I once did. That okay, everything's configured, everything's built, like deployed, no messages. What is going on? So libp2p works, gossip sub works better when you subscribe to channels. Yeah, and we right now, we've got there's little numbers here because this is supposed to be a short presentation, but we've got 25 nodes that are publishing messages. We've got a few more that are collecting them, analyzing, and recently I actually found a tool called Nebula by Dennis. That's yours? No? Oh, okay. So I found Nebula, and this tool is really nice to discover the participants of the network and crawl the DHT. So that's what it's for, and it's quite helpful. So we've got 25 nodes that can publish, and then we've got a few more that read data and analyze it. Yeah, I didn't mention that we've got some bootstrap nodes, as is typical for a mesh network. Like the discovery cannot happen on UDP or whatever, like that requires them, like the machines, to be on the same network, because it's a distributed system. And actually, what's important is that we do not control the machine the machines except for one, just to like have the logging and see what's going on if the network is breaking. But usually, since we don't control it, we need some other way to look into the system. So like analyzing the traffic helps a lot. We've got we are producing like a few thousand messages per minute, because every minute they are sending a burst of messages, and at least from the business side, from the domain, the Oracle domain that we have in our code, but on libp2p we are trying to tweak everything we can to make things more optimal. So sometimes if we have too many messages, like the network of course chokes, but it's not a problem of libp2p, it's a problem of the signature. Signing messages is expensive, and then we needed to raise the buffer, like make the buffer, I think it's right now for 4,000 messages in the buffer, in the message buffer for libp2p. Like we just put the 4,000 everywhere. It made a large difference, and it helps a lot. So that's what we did. This is a QR code to our dashboard. If you want to see like the outcome of the whole Oracle protocol and Oracle system. And yeah, I just want to say that like I'm really glad that libp2p became a separate project, separate from Filecoin? No, IPFS. Sorry, yeah. So I'm really glad that it's separate, and it's moving in an interesting direction, and I'm quite looking forward to using more of the options like the browser communications, WebRTC and stuff. Yeah, so that's basically it. If you guys have more questions, or if you are interested in some more numbers, I can create some presentation or something and send it your way to show more numbers. But basically, yeah, we love libp2p. And yeah, that's our message. Do not trust, verify, because yeah, like everything in the network, like we just assume it's fake. We need to have a way of verifying. That's why everything's signed in our network, and there's no room for any mistakes, because $8 billion can like go poof in an instant. Yeah, and that's it from Chronicles. I'm Pawel, and thank you very much. You can see. As you can see, I'm a fan of Star Wars. No one gets that joke. Okay, Star Trek. Remember, Star Wars? No, Star Trek. Thanks. Do you have any questions, maybe? No questions. Okay, yeah.
What's the average message size in the network? Do you know that?
Yeah, the average message size is somewhat below 1 megabyte, and we've limited that to 1 megabyte, so we don't get too much traffic, because what do you know? Traffic costs. like right now, this is the biggest cost for the validators, that the traffic. We are trying to group messages. We also implemented compression. Just zip the messages and send them in a group. But yeah, still, like it creates a lot of traffic, and the more validators we have, the more traffic there will be, and that's required. And Schnorr signatures, okay, if I'm talking, Schnorr signatures are even worse for this, because you need commitment collected from everyone, then you need another commitment collected from everyone, and only then you can create a final signature. This is, it is what it is. So, but we're managing that. There should be another oh yeah, this question.
Thank you very much for the presentation. Can you elaborate on your experience upgrading between libp2p versions? And if there are, from your perspective, anything, like any particular points which could be done better, if at all?
So, like this 3 years ago that we started, 3 or 4 years ago, we started using libp2p very extensively, and then like we had that version, like whatever it was, and then after a while we wanted to upgrade, and then there was a lot of incompatibilities, even though the versions actually didn't say, the semver didn't say it was that. And another thing is the documentation. Like there's multiple layers in libp2p, and I understand that's probably required, but like debugging it and making everything compatible between versions also probably is a nightmare. So I totally understand that it's hard, but like it was usually the interfaces changed quite a lot, and they weren't backward compatible.
Yeah, and just to add to that, I think that is more of an implementation specific like conundrum, because I can say, unfortunately, being a maintainer on JS libp2p, the DevX hasn't necessarily been the best when it comes to how we've done breaking changes in the past. So I'm glad that your experience with Go libp2p has been relatively smooth.
Yeah, like we just spend a few more days than we expected, but we do it, so it's fine. And like we build out the bootstrap node separately, we build out the validators separately, the relays separately, so we go very, very deep into the stack of libp2p. So yeah, like it's nice. Like I really like libp2p for the simplicity on the top level, and then if it gets complicated a little bit deeper, that's how it is. It wouldn't be so good if it wasn't complicated. Simplicity is complicated. All right. Any more questions? I don't see. Then thank you very much.
Thank you.